All right, so let's work some VCAA transformation problems. So we've got transformation which maps this function here to this function here. Okay, so what we will do first, I think, is work out or determine the transformations. So we've got y equals log e x and y equals log e 2x take 4 plus 3. You might also be able to do it via some recognition as well, but I'm going to do this via mapping. Y take 3 or y dash, x dash. Y take 3 equals log e 2x dash take 4. Pair them up. Y equals y dash take 3. X equals 2x dash take 4. All right, what we'll do is we'll make x and y the subject, x dash and y dash the subject, so we can get the transformations. Okay, so it's going to be y plus 3 equals y dash, and that's going to be x plus 4 over 2, x plus 4 over 2. Okay, so let's have a look at the way this is going to work. So what's going to happen is we want to work out which one is going to give us the same mapping. So this would be the first one, x on 2 plus 2, and that's going to be y plus 3. Now, that one there is in fact the correct one. Okay, and why? Well, because that's going to be x on 2 plus 2, comma, y plus 3, which is the equivalent version of that. So that's our answer. This one here is x on 2 plus 4, y plus 3. That's take 4, so that's not even the right direction. That one there is, yeah, no, can't be right. So yeah, definitely this one here. Noting that it's interesting, if you try to do that via recognition, I wonder how you'd go. What you could do is get it to single x, so log e 2, x take 2 plus 3, and note that this is a translation, so dilation factor half from y, so that's that, 2 to the right, and 3 up. So that's another way you could do it, is by recognition, going to single x. That'll help you out with that one there. Although again, there was an interesting question last year that involved going to single x that wouldn't give you an equivalent answer. So yeah, that's just one strategy. You got to have a few things in your bag of tricks. Right, the transformation with this rule maps. So 38% of the state got this one right. Maps the equation of y equals x cubed with one of these. Okay, so what we'll do is we'll go x dash is equal to 4x plus 1 and y dash is equal to negative 2y plus 3. Okay, now what we'll do is make x and y the subject. So x dash take 1 over 4 equals x, and y dash take 3 over negative 2 equals y. Okay, bang them in. Y take 3 over negative 2 equals x take 1 over 4 all cubed. Okay, that is going to be x take 1 cubed, 4 cubed, 16, that's going to be 64. Y take 3 over negative 2. Right, when I multiply by negative 2, what will happen is the negative 2 will cancel out with the 64, meaning I've got y take 3 equals negative x take 1 cubed over 32. And then we're going to add 3 to both sides. So let's just quickly do that, plus 3. All right. A again, is it? Let's feel a bit sus, like, ooh, this should be sort of spread around a bit, but yeah, let's go with it. Yep, okay, move on. Okay, so I'm just going to redo this 2010 exam 1 question because I actually did the thing on the calculator, not realizing that it needs to be done by hand. I'll still show you how to do it on the calculator, but let's do it by hand first of all. So image of this under this transformation has an equation of this form, and we want to find A, B, and C. So let's go x dash equals 3x take 1. So I'm just going to work out the mapping. Y dash equals 2y plus 4. Okay, so what we need to do is make x and y the subject, so I can pop it into the original so I can create the image. X dash plus 1 on 3 equals x, and y dash take 4 on 2 equals y. All right, let's pop them in. So I've got y dash take 4 all on 2 equals 2x plus 1 on 3 all squared plus 1. Okay, so I think what I'll do first of all is I'm going to multiply by 2. So y dash take 4 equals 4x plus 1 on 3 all squared plus 2. I'm going to add 4 to both sides, so that's going to be y dash equals 4x plus 1 over 3 squared, take 2. Okay, add 4 to both sides, you clown. Okay, 6. Okay, so now what I'll do is start to manipulate. I'm just going to drop this dash as well. So I've got 4x plus 1 squared over 9 plus 9 sixes are 54 over 9. Y equals 4x squared plus 2x plus 1 over 9 plus 54 over 9. Y equals 4x squared plus 8x plus 4 all over 9 plus 54 over 9. Now let's split it up so that we can get the coefficients. 4x squared over 9 plus 8x over 9 plus 4 over 9 plus 54 over 9 is 58 over 9. A equals 4 ninths, B equals 8 ninths, C equals 58 over 9, which is what I got when I did it by hand as well, so that's good. Right, how did I, but on the calculator rather. So how did I do it on the calculator? Well, what I know is that if I start with this function here, f of x, I can create a new function g of x by doing this transformation here. This is a dilation factor 3 from y. So that's going to be f of x on 3. Then what I'll do is this translation 1 to the right. So that's slamming in x plus 1 where I see x on 3. Hj of x is equal to, so this is a dilation factor 2 from x, so that's 2 f of x plus 1 on 3, and I can do the add 4 to it at the same time. So you can see here what I did on the calculator was defined that function, did that particular thing to it, got this, expanded it, and got my quadratic as well. So 2 ways of doing it, calculator and the by hand method. I prefer the calculator for the record. Okay, wow. 2012 exam 2, 8% on this one. Okay, transformation that maps. That has this rule here. So it's got a, well, maybe not a dilation factor 2 from the y-axis. Okay, so find the values of A, C, D. Okay, so what do we got? Let's go from y equals, that's the graph of f. So this onto G is the one on X. So basically they want to undo all of this stuff. So y equals 1 over 2x take 4 plus 3, 2, y equals 1 on X. Y take 3 equals 1 over 2x take 4, 2, y equals 1 on X. Okay, so that's dash and that's dash. What we could do is pair this up, but what I know is that, or what I'm pretty sure is that it's got some sort of dilation from y. Okay, I'm just going to do this. So y take 3 equals y dash. Yep, okay, so that's going to be x dash, y take 3. So I think this one here, d, is going to equal -3. Okay, x dash, 2x take 4. Okay, so that is that, with a negative, yeah. So I believe a equals 2, c equals -4, and d equals -3. So A, C, and D are non-zero. Oh, it sort of feels like there's got to be a bit more to it than that, but no. 2x take 4, y take 3. Yep. Okay, looks good. And this one here, transformation, that maps the graph onto that. The rule of f is, okay, so that's the graph of a function f of x. So from y equals f of x to y equals x squared. Okay, so some sort of parabola has this stuff done to it to form this basic graph here. Right, so what are the transformations? It's a translation, 5 to the right. Okay, so that's, yeah, 5 to the right. And it's a reflection in the x-axis. All right, so basically what I'm looking for is a parabola that's currently 5 to the left. Okay, so I want a parabola that's 5 to the left so that when it moves back here. Okay, so I'm looking at a parabola that looks like this. X take 5 squared and a reflection in the x-axis. So I'm looking at a parabola that's inverted. That's that one there. Right, so I better not call it f of x, I'll call it g of x. So g of x has the translation 5, right? And reflected in the x-axis, and it'll become this graph here. So C, I believe, is our answer. Okay, final question here. Transformation with this rule, that's line with this equation onto the line with which equation? So this is x dash equals -x plus 1, y dash equal to, you can hear my wife sneezing in the background there, 2y take 2. Okay, so what we'll do is make x and y the subjects. So x dash take 1, all negated, equals x, y dash plus 2 over 2 equals y. Okay, so let's pop them in. So I've got, for x, I've got negative x take 1 goes in. I'm just going to drop my dashes straight away. Take away 2, y, what does that take away? Plus 2. Y plus 2 over 2 equals 3. Okay, negative x plus 1 take away, so that's going to cancel with that. Y take 2 equals 3. Negative x take y equals 0. What's going on? What's going on here? Negative x take y plus 1 take 2. Oh, God. Right, so take 1 equals 3. Add 1 to both sides. Negative x take y equals 4. Okay, so lucky that one wasn't there, because otherwise I would have chosen it, because I backed myself, girls. Right, so there is the VCAA questions. So we've got 3I, 3J. There's going to be a worksheet as well. Transformations, girls. Practice, practice, practice. Matrices, it's pretty hard. Okay, but you just got to practice these things.